Assalamualaikum and hi everyone. So in this video we will continue the last two subtopics in chapter 2, the implicit differentiation and linear approximation. On the previous examples on how to differentiate functions, we only discuss the type of functions that are called explicit functions. Meaning that the function is clearly expressed in the term of x only. We have only one variable, which is in the function of f of x. So the function of variable x only. These types of function are called as explicit function. So in this subtopic, we are discussing on how to differentiate implicit differentiation. An example of implicit differentiation is like this expression. We have here 3y square minus 2x square equals 2xy. So this is the example of implicit differentiation, where we can see here y cannot be clearly expressed in the term of x only. When we try to express y, we'll get like this, 3y square minus 2xy equals 2x square, and then we cannot express the term like y equals what. Dekat sebelah kanan tak boleh kita letak term of x only and y sebelah kiri, tak dapat. So this is the example of implicit function. We cannot express y in the term of x only. So how to differentiate this type of function? There are two steps here. The first one is you need to differentiate both sides. Can you differentiate both sides of the equation with respect to x? For every terms that involve differentiation of y, so you need to put dy over dx at the end of the term. And if you are differentiating the variable x, you don't need to put dy over dx at the end of the term. Only if you are differentiating y. And for the second step, you need to make dy over dx as the subject of the equation. So that's how to differentiate the implicit function. So let's take a look at this example. This is one of the example of implicit function, where we cannot express y as the function of x only. So how to differentiate this function? According to step 1 just now, we need to differentiate both sides, all the terms on the left side and right side. If you are differentiating variable x, you can differentiate it according to what we have learned before this. And if you are differentiating the variable y, make sure you put the xy dy over dx at the end of the term. So we are differentiating both sides. So we need to put d over dx, left side and right side, and then we need to differentiate each of the terms. So differentiate x cube. We will get where is it? It's okay, you don't need to look at this solution, so I will do my own solution here. So we are differentiating x cube, y cube, and also for xy. So we need to differentiate it one by one. So when we differentiate x cube, So we are differentiating the variable x, so we don't need to put dy over dx at the end of the term. So just differentiate x cubed, we will get 3x squared. Okay, and then plus. Okay, next we want to differentiate y cubed, y power of 3. So this time we are differentiating the variable y, so we need to put dy over dx at the end of this term. So y cubed, when we differentiate it, we will get 3y squared, and then we need to put dy over dx. Okay, each time you are differentiating the variable of y. Okay, and then equals. Okay, for xy. To differentiate for xy, we need to use the product rule. Okay, before it is connected. For x and y is connected by multiplication. For x multiply with y, so we need to use product rule. So for this term, okay, we assume our for x as our u and y is our v. Okay, so letak buat dekat sini, tepi sini, our u is for x and our y, v is y. So we need to find u prime, which is 4, and v prime, which is equal to 1, and then we need to put dy over dx because we are differentiating the variable of y. Okay, dekat sini tak payah letak dy over dx sebab kita differentiate the term of x. Okay, ini y, kita anggap dia sebagai x. Kalau you are differentiating x, so it is equal to 1. So this time also, kalau kita differentiate y, it is equal to 1, but we need to add dy, we need to put dy over dx. Okay, so by applying a product rule, okay, we need to write u v prime plus vu prime. Okay, letak dekat left side, right side. So our u v prime will be for x dy over dx. Okay, and then plus with vu prime. Okay, vu prime is for y. Okay, so this is the resulting equations when we differentiate both sides and term by term lah dekat dalam original functions ni. Okay, and then we need to make dy over dx as the subject. So you need to bring each terms containing dy over dx into left side. Okay, so 3y squared dy over dx. Okay, this term you need to bring it left side, so minus 4x dy over dx. Okay, and then the term did not contain dy over dx, so you need to bring it right side. For y, okay, minus 3x squared. Okay, and then we want to make dy over dx as the subject. So here we need to factorize dy over dx. So in a bracket we have 3y squared minus 4x, okay, equals 4y minus 3x squared. So make dy over dx as our subject. We will get 4y minus 3x squared divided by 3y squared minus 4x. So that's the answer for this implicit differentiation. Okay. Okay, so you can see here we get the same answer. Okay, next we want to differentiate this function, where this function is also an implicit function. So we need to differentiate term by term, differentiate secant x, and then differentiate xy square, and differentiate to x cubed. Okay, to differentiate this term xy square, we need to perform product rule because it is x multiply with y square, so we need to perform product rule for this term. Okay, secant x. Okay, when we are differentiating secant x, we will get secant x tangent x. Okay, and for this term we don't need to put dy over dx because we are differentiating the variable x. Okay, so equals, and then just now I said we need to perform product rule for this term. So we assume our u is x and our v is y square. Okay, so find u prime and v prime. So our u prime is 1 and our v prime is, okay, differentiating y square, so we'll get 2y, and then we need to put dy over dx because we are differentiating variable y. Okay, so insert it into the product rule, which is uv prime. Okay, so our uv prime is 2xy dy over dx, and then plus with vu prime, which is y square. Okay, and then plus with, okay, the last term 2x cube. Differentiate 2x cube is equals 6x square. Okay, and then we need to do some simplification and modification to make dy over dx as our subject. So the term containing dy over dx, we need to bring it left side. Okay, so we'll get negative 2xy dy over dx equals y square plus 6x square minus secant x tangent x. Okay, and then dy over dx tangent x, okay, divide by negative 2x square. Usually you in fraction we don't put negative in the denominator, so we need to change all the operations here. All the positive will become negative and all the negative one will become positive. So our dy over dx is equals negative y square minus 6x square plus secant x tangent x divide by 2xy. Okay, check with the answer here. So we get the same answer. Okay. Okay, next example. Okay, this is also the example of implicit function. So we need to differentiate term by term. Okay, the first one is for this term x square sine y. So this one we need to solve by using product rule. Okay, because it involves two terms that multiply each other, which is x square multiply with sine y. So we need to perform product rule for this term. For this second term, 2x, so we differentiate it into x 2x differentiate jadi 2, and then y square differentiate biasa lah. Okay, so the first one kita differentiate this first term. So our u is x square and our v is sine y. Okay, and then u prime equals to x and v prime. Okay, sine y differentiate it will become cos y, and then don't forget to add to put the term of dy over dx because we are differentiating the term of y. So then we solve by product rule, which is uv prime x square cos y dy over dx plus vu prime, okay, which is 2xy. Okay, this is the resulting the resulting terms when we are differentiating this one. Okay, and then plus with 2x differentiated, it will become 2. Okay, and equals y square, differentiate y square, we will get 2y, and then we need to put dy over dx. Okay, and then bring all the terms containing dy over dx on one side and all the terms didn't contain dy over dx on the other side. So dy over dx minus with 2y dy over dx, and then negative 2 minus 2xy, and then we need to factorize dy over dx. So in bracket we have x squared cos y minus 2y, okay, equals negative 2 minus 2xy. Okay, then our dy over dx will be negative 2 minus 2xy divided by x squared cos y minus 2y. So you can check here, we have the same answer comparing on the solution in this book. Okay, this one. Okay, sama tadi. Okay. Next one, we continue with the last subtopic in chapter 2, okay, which is about linear approximations and differentials. Okay, first let us take a look at this formula for linear approximation. Okay, this formula is derived from the definition 2.2 when we replace the x and h with x naught and difference of x respectively. Okay, in definition 2.2 we have learned about the formula of f prime. Okay, f prime x equals limit h tends to 0, where f x plus h minus fx divided by h, okay, where this formula is called the first principle, okay, the first principle of differentiation. So we replace each of x, okay, with x naught, and h replaced with difference x. So we'll get from this formula, we'll get f prime, okay, x replaced with x naught, okay, then limit, so kita kena buat macam ni lah, okay, sebab jawapan dia lebih kurang, limit, and then f x naught plus difference of x, okay, minus f x naught, okay, divide by difference of x. Okay, and then kita darab silang, so kita akan dapat yang ni. Okay, so simplify this equation, we'll get this formula. Okay, we call this formula as linear approximation. So we can use this formula to find the approximate value of functions, such as if you are given square root 4, 0, 1. So the question asks you to find the approximation of this value. Okay, so we can use this formula of linear approximation to find the approximation of these values. Okay, we do not want to find the exact value. Okay, kita bukan nak cari exact value, because the exact value you can find it easily by calculator. So we use this formula to get the approximation, okay, approximate value. Okay, for example, okay, look at example 2.21. We want to find the approximation of this expression, which is cube root of 8.02. If you are using your calculator, you will get the answer of 8.02. Okay, if you are using calculator, your answer will be 2.001066528. But this time we need to use this formula, okay, to find the approximation. Okay, So if we are using this formula, so we need to determine what is our x, what is our x naught, and what is our difference x. So in this case, our x is at 8.02, which is this term lah yang dibagi kat sini. Okay, so we determine our x as at 8.02, so that our function will be cube root of x. Okay, because our x is here, so this function will be cube root of x. So our fx is equal cube root of x, and it is equals to x power of 1 over 3. Okay, next we want to choose the value of x naught. Okay, x naught. X kita dah dapat dekat sini. Okay, next we need to choose our x naught. Okay, our x kita dah dapat, our fx pun kita dah dapat. Okay, x naught. Usually when we want to choose the value that is an integer and is close to x value, okay, kita kena cari x naught yang okay, usually we choose our x naught as an integer and close to the x naught value. Okay, x naught kat sini. Okay, just now our x is 8.02, so we want to choose x naught. Okay, x naught usually we choose an integer, okay, which is close to 8.02, so we can choose x naught as 8. Okay, so ini 8 kat sini, bukan 8.02. Okay, ada typo kat situ. Okay, next, what is our difference of x? Okay, difference of x actually is x minus with x naught. Okay, so yang ni tolak dengan yang ni, so akan jadi 0.02. Okay, so kita dah dapat our fx is x power of 1 over 3, and our x is 8.02, x naught equals 8, and difference x equals 0.02. Okay, so after that we just have to insert all of this into this formula. Okay, dalam formula ni tadi f x naught, so here we have f, our x naught is 8, okay, f8 plus f prime 8 multiply with our difference x, which is 0.02. Okay, so kita dapat macam ni lah. Okay, this is the formula for approximation tadi. Okay, so f8 plus f prime 8 multiply with 0.02. Here we need to find what is our f prime first. Okay, so since we have our function is x power of 1 over 3, so we can have our fx like this. Okay, 1 over 3 x power of 1 over 3 minus 1, which is negative 2 over 3. So this is our f prime x, and then just insert into the formula, so we'll get 8 power of 1 over 3, okay, which is f8. F8 ni maksudnya masukkan 8 dekat dalam function yang asal. Okay, so we'll get 8 power of 1 over 3 plus f prime 8 means that we need to insert the variable 8, x equals 8 into f prime x, so we'll get 1 over 3, 8 power of negative 2 over 3, and then multiply with 0.02. Okay, ini just guna calculator saja, so we'll get this value. Okay, when we check this value, okay, 1201 divide by 600, so it is equals to 2.0016667. Okay, lebih kurang macam yang tadi, yang guna calculator tadi. Okay, this is the exact solution, and this is the approximate solution using differential formula, approximation formula. Okay. Next example, okay, we need to approximate the value of this one. Okay, next, look at this example. The same type of question like the previous one, where we want to approximate the value of this one, okay, by using formula of differential. Okay, so we determine our x, okay, as this one, okay, 101, so that if this is our x, so this function will be 1 over square root x. Okay, this is our function where it is equal to x power of negative 1 over 2. Okay, and then from this value of x, next we need to determine our x naught. So what will be our x naught? Usually we choose an integer as our x naught. From the previous example just now, our x is 8.02, so we choose x naught equals 8. Okay, we only take the integer part. But this time, our x is already an integer. So what will be our x naught? So we can choose our x naught as 100. Okay, 100. So our x 101, x naught is 100. So the difference of x is 1. Okay, tolak dua-dua ni. So our difference x is 1. And then, okay, just now I said that our function will be like this. So it is here. And then we need to find f prime. Okay, f prime x. So differentiate this one. So we will get, okay, differentiate fx, we will get f prime x negative 1 over 2 x power of negative 3 over 2. And then just insert into the formula for differential, where f x naught, so our x naught is 100. Okay, 100. So we get f 100 plus f prime 100 multiply with the difference of x, which is 1. Okay, f 100 means that we need to substitute 100 in our f function of f. Okay, and then f prime 100 means we need to substitute 100 in f prime x. Okay, and then multiply with 1. So just use your calculator. So you'll get this value. Okay, so this is the approximation of 1 divided by square root 101. So you can compare this answer, okay, with using calculator for this expression. Okay, awak guna calculator, tekan 1 divided by square root 101. So you can compare the answer given by your calculator with this answer. Okay, it's not so different. Okay, tak banyak sangat perbezaan antara dua jawapan tu. Okay, so this is the end of chapter 2. What we have learned so far in chapter 2, the first one, we learned about the concept of differentiation using first principle. Okay, and direct differentiation using quotient rule, product rule, and then how to differentiate a log function, trigo function, exponential function, and how to use implicit differentiation. And then finally in this video we have learned about the last one is about this formula of differential. Okay, so this is the end of chapter 2. So please do tutorial as I mentioned in your group Telegram. Okay, Assalamualaikum warahmatullahi wabarakatuh.